Hello my dear students, how are you? I hope that you will be very well and I am also very well. Today I am going to discuss question bank of IIT JEE related to laws of motion. I have already solved question number 1 to 10 in previous video. Today I am going to solve question number 11 to onwards. A block of mass 0.1 kg is held against a wall applying a horizontal force 5 Newton on the block. Suppose this is one. A block is pushed against a wall and mass of this block is 0.1 kg. Okay. A horizontal force. A block of mass 0.1 kg is held against a wall applying a horizontal force 5 Newton on the block. Okay. This is 5 Newton. If the coefficient of friction between the block and wall is 0.5, here friction of coefficient 0.5, the magnitude of frictional force acting on the block. We have to find magnitude of frictional force acting on the block in this situation. This block is in equilibrium, therefore net external force will be equal to 0. First of all, we consider in horizontal direction. This force is balanced by normal reaction exerted by the wall on the block. Okay. First of all, we find maximum friction, that is limiting friction. What will be limiting friction? If maximum is equal to mu into n. What is the value of n? In horizontal direction, net force acting on this block will be equal to 0. Therefore, n is equal to 5 Newton. N is equal to 5 Newton and mu is given, which is equal to 0.5 and n is 5. This will be equal to 2.5 Newton. Okay. Gravitational force is acting on the block in downward direction. What will be its value? This will be equal to mg. Mass is 0.1 and g is 9.8. This will be equal to 0.98 Newton. 0.98 Newton. Okay. Friction force. This force can move the block in downward direction. Friction force always opposes the tendency of relative motion. Due to this gravitational force, the block has tendency to move in downward direction, and friction force always opposes the tendency of relative motion. Therefore, friction force will act in upward direction. Okay. Maximum friction is 2.9 Newton, but here mg is 0.98 Newton. This force acts as an external force. If external force is less than maximum friction, then the friction acting on the block will be equal to applied force or external force. Okay. Here gravitational force acts as applied force. Here applied force is less than maximum friction. Therefore, friction acting on the block will be equal to applied force. Therefore, F should be equal to 0.98 Newton. Since mg less than F max, therefore F should be equal to applied force. mg acts as applied force. Here applied force is less than maximum friction. Whenever applied force is less than or equal to maximum friction, that is limiting friction, then friction acting on the block will be equal to applied force. Okay? Got it? Now I am going to solve next question. Question number 12. A long horizontal rod has bead which can slide along its length and is initially placed at a distance L from one end A of the rod. Here situation is like this. This is a rod. Okay, and this is bead. This is bead. Initially, it is at a distance L from A. Means this bead is at this point. Okay. L from one end A of the rod. The rod is set in angular motion about A with constant angular acceleration alpha. Means constant angular acceleration alpha. Here this rod is moving like this. Okay. Angular motion about A with constant angular acceleration alpha. If the coefficient of friction between the rod and bead is mu. Here friction coefficient is given, mu is equal to mu. Okay. And gravity is neglected. Then time after which the bead starts slipping is initially bead is at a distance L from the end A. Means this bead is here. Okay. Actually this rod is moving in like this horizontal direction. Okay. Suppose this is bead and this rod is moving with angular acceleration alpha. Therefore, tangential acceleration of this bead will be equal to R alpha. Here R is L alpha. Okay, this is tangential acceleration. If tangential acceleration is at, therefore if you draw free body diagram of a bead with respect to non-inertial reference frame whose acceleration is this, then a pseudo force acts on the bead. If this is bead, pseudo force acting in this direction, because acceleration in tangential acceleration has direction in this direction. Okay, therefore pseudo force acts in this direction. Normal reaction acts in forward direction and pseudo force acts in backward direction. Okay, both will be equal. Therefore normal reaction will be equal to mass of the bead, pseudo force will be equal to mass of the system, and acceleration of non-inertial reference frame. Here acceleration of non-inertial reference frame L alpha. Okay, this is normal reaction. Therefore friction will be, maximum friction will be mu m L alpha. You can solve this question in inertial reference frame. If you consider inertial reference frame, then tangential force will be equal to this. Okay, and tangential force will be equal to normal reaction exerted by the rod on the bead. This is normal reaction. This is maximum friction. Bead can slide if centripetal force will be greater than or equal to F max. Okay, bead can slide if centripetal force is greater than or equal to limiting friction, that is maximum friction. Here centripetal force is equal to m omega square L. Here F max is mu m L alpha. Okay, m cancel out, L is also cancel out. Here omega square greater than equal to mu alpha. Now I am going to find omega. Here rod has angular acceleration alpha. Therefore angular speed at time t. How to find? Time after which bead starts slipping. What is the time after which bead starts slipping? Okay. First of all, we find omega at time t. We know that omega is equal to omega naught plus alpha t. Okay, this is rotational. This is equation of rotational motion. Omega initial angular velocity is 0. This is alpha into t. This will be equal to alpha t. Omega is equal to alpha t. Okay, mu alpha. We have to find t from this equation. T square greater than or equal to mu alpha upon alpha square. Okay, therefore t will be greater than or equal to root under mu upon alpha. Okay. If t is greater than or equal to root under mu by alpha, bit will start. Initially, t is equal to root under mu by alpha. At this time, the bit will start. The bit will start. Start sliding at t बराबर रूट अंडर म्यू बाई अल्फा. ओके, ठीक है. Therefore, option will be equal to, correct option will be equal to A. This is the correct option. Now I am going to solve next question 13. Okay. The pulleys and strings shown in figure are smooth. Here, pulleys and strings shown in figure as smooth and negligible mass. This means that a string and pulley are massless and smooth. Okay. For the system to remain in equilibrium, the angle theta should be equal to. System is in equilibrium means net force acting on the system will be equal to 0. This is T, this is T. Okay, and this is T1 and this is T2, and this is root 2 mg. Okay, all forces, first of all forces make in horizontal or vertical direction. This is in vertical direction, this is not in horizontal or vertical direction. Therefore, we draw its component. This component will be T2 cos theta, and this component will be equal to T2 sin theta. Similarly, draw component of T1. This component will be T1 cos theta, and this component will be T1 sin theta. Okay. This force is resolved in two parts. Therefore, this force has two parts, this and this. Okay, this force has two parts, this and this. Since net external force acting on the system is 0, therefore T1 sin theta should be equal to T2 sin theta. Therefore, T1 is equal to T2. Okay. Now, considering vertical direction, T1 cos theta plus T2 cos theta is equal to root 2 mg. T1 is equal to T2. Therefore, suppose T cos theta plus T cos theta is equal to root 2 mg. Therefore, T is equal to root 2 mg by 2 cos theta. We have to find angle theta. We have to find angle theta. What is the value of theta? This will be equal to mg divided by root 2 cos theta. This is tension. Okay. We have to find angle theta. Now I am going to draw free body diagram of any of these blocks. This is mg and this is tension T. T1 T2 is equal to T1 बराबर T2 is equal to T. Okay. This will be equal to T1 is equal to T2. Therefore T is equal to, this block is in equilibrium, therefore net external force will be equal to 0. Means T is equal to mg. Now I am going to put the value of T. T is mg. Okay. mg cancel out. Therefore cos theta is equal to 1 upon root 2. 1 upon root 2 for which angle? Theta should be equal to 45 degree. Okay. Here theta is 45 degree. This is the answer. This will be equal to, this will be correct option, 45 degree. Okay, got it? Now I am going to solve question number 14. This question had asked in IIT in 2001. A string of negligible mass going over a clamped pulley of mass m supports a block of mass m as shown in figure. The force on the pulley by the clamp is given by. We have to find force on the pulley by the clamp. This is clamp. This is called clamp. Okay. This is This is clamp. We have to find force exerted on the force exerted by the clamp on the pulley. First of all, we draw the free body diagram of pulley. This is free body diagram of pulley. Okay. Pulley has mass m. Pulley has mass m. This is tension T and this is tension T. Okay. And this is gravitational force mg. Now I am going to draw free body diagram of block of mass capital M. This will be equal to T and this will be equal to mg. Okay. This means T is equal to mg because system is in equilibrium. What will be the value of T? This will be equal to mg. Okay. Net force in downward direction will be this plus this, mg plus mg, and in this direction will be equal to T. T means mg. Okay. Resultant force will be like this. This is the resultant force. Okay. This is resultant force acting on the pulley. Acting on the pulley. If clamp is not present, then pulley move towards resultant force. Okay. This clamp exert a resultant force in this direction. Therefore, net force acting on the pulley and force exerted by the clamp cancel out. This will be equal to Fr is equal to root under mg square plus m into g square. Okay, ऐसा g will be outside from the root and inside the root will be m square plus m whole square. Okay, this will be equal to force exerted by clamp on the pulley. According to Newton's third law, this is the force exerted by clamp on the pulley, and according to Newton's law, force exerted by pulley on the clamp also will be equal to Fr. We have to find force exerted by clamp on the pulley. This will be force exerted by clamp on the pulley. This will be equal to force exerted by clamp on the pulley. This is the answer. Okay, which is correct? G outside from the root and capital M square plus m whole square. This. Okay. D option is the correct option. I hope you understood all questions and their solutions. Now I am going to end the class today. Have a nice day. See you again tomorrow. Namaskar from my side.